errors. Okay, so please download your own report and take a look at it. And here I want to sort of, okay, just highlight, I not sure about this Brian's report here. Who is the one who do it? Okay, and also Adin's report. I remember I mentioned that, okay, change the background to no color or white color. All right, so this one here, at least still can see something, but Adin one, some of the, this waveform report here, there's no waveform at all. All right, and over here, I want to mention another thing is, I remember I stressed that, okay, don't use the word V. And in this part here, there are so many V here, you know, until tak boleh tahan, I just circle lah. All right, so who is the one who wrote this V here and he likes the V so much? Brian, Ming Hang, and Yin Xian. 3 of you here. Class, okay, finish checking. And Song Jian and Jian, my counter is asynchronous, okay, reset. But you all go and put the synchronous reset there. Okay, Jian and at least Song Jian, be careful, okay? But you all did something extra lah. That's why your mark still looks very good. Okay, I give credit to the extra work that you all have done. Now, have you all finished checking? Now, just do the additions, okay? Check whether I made any mistake in summing up all the marks. The marks that I am going to record in the internet. And Corwin, okay, I'm very generous, okay, in marking this lab report because I think, okay, you all are doing, okay, good report. So be very careful, okay, in your this coming exam here. I'm a little bit worried, okay? Your group mark, Ming Hang's group mark. I add wrongly, you mean? I double check, Ming Hang. Ming Hang. Brian Tang. Ming Hang is it, yeah. Oh, yeah, okay, my mistake. 6, 13, 11, 7. Okay, so I will change this. actually I wanted to give you 36 only, is it? Yep, 37. Okay, I will change in the record lah, don't worry. Okay, 7. Okay, any other mistake that I make? Now, who is the one who keep on writing the V? Ming Hang, is it you? Suddenly forgot not to use V. What suddenly forgot, okay? Just keep in mind, okay? Every time writing report, don't use V, Okay, any other, okay, feedback? On the additions? Well, if no more, right? So I will, okay, later on, okay, change this mark. So I guess if I'm not mistaken, okay, for this coursework mark here, only 2 got A. Okay, so 1A minus, 4B plus, okay, others all 1. Okay, so if there's no questions here, I think, okay, this hour here, I'm going to do my lecture first. Okay, I finished the ASM, then we are going to focus on tutorial. Okay to all? Now, this is this group assignment here, I give marks, okay, very general, but I do suspect that, okay, maybe one or two of you lah. Actually, it's just a tag on. Tag on means, okay, you're actually not really doing your work. Maybe you rely on your partner. All right. Now, VHDL here, okay, there's one question on this coming final exam. And this final exam already confirmed. As all the SOP came out already, okay, for the physical exam. Okay, so please memorize something, especially those syntax. All right, for VHDL as well as for all the truth table, application table, all these, okay, please memorize. In the exam, if you are found, okay, take in any notes related to the subject, then it's considered copy. There's no more open book, okay, it's considered copy. All right, cheating. So your marks is either fail, okay, fail, and consider as this paper I no need to mark already lah, so we fail. Even though I mark also, finally, okay, result is usually fail. So I don't want to see these things happen. And I also understand that, okay, you're almost, okay, 2 years, never do any this physical exam. So the brain here is like no need to remember anything one. Okay, anything also can refer lah, but not coming for this, not for this coming exam. Please, okay, start from now, still got 1 month time. All right, memorize, okay, some of the necessary thing. Cannot remember, okay, don't, if you cannot remember, okay, keep on writing, okay, for 10 times. Zian, too late, exam question, okay, only start printing. we submit the exam question somewhere in the 3rd or 4th week. All right. So, but I look at the question here, nothing, okay, that difficult. Now, I keep on reminding you all is, okay, 5 input variables will come out. Okay, so please, okay, make sure you know how to do looping, how to fill up a kernel map of 5 input variables. Okay, this is one of the guidelines already, Ren Jian. The rest, okay, no standard, okay, VHDL, no sequential, combinational, okay, the 5 input variables only 12 mark. These are coming exam. I cannot remember exactly how much already, okay? Because like I say, okay, we submitted the question, okay, long time ago. But anyway, please, okay, start from now. Please try to memorize something. Not only my subject, all other subject also. Otherwise, your marks will be very ugly, okay? And I keep on telling other groups of other lecturers that this group of students are good. They are hardworking. Okay, so we talk about these revisions. We talk about this revision everything later. Okay, let us finish our work. And in the tutorial, I do hope that, okay, more students, okay, will contribute. Okay, don't just focus on EMF lah. All right, spare some time, okay, for this subject. Although this subject is considered one of the easiest one. All right, so EMF this time I'm expecting, okay, very okay, very high failure rate lah, especially those some repeat students like it the okay. All right, never mind. We focus now, okay, back to our lecture first. Okay, let me finish this lecture, then, okay, we will do our tutorial. Okay, now lecture I will share. Okay, this last topic here. Let me take out this. All right, okay, back to here. Let me record down. Hey. Okay, this topic here is on ASM, okay, the short term for algorithmic state machine. Again, okay, it is related to your sequential circuit state machines. So in this ASM here, you are going to find that, okay, we use something like a flow chart. Okay, we use something like a flow chart. Okay, instead of using a state diagram to represent those circuit that we are going to design. So here tells you when this standard is used, the state diagram is constructed in the form of a flowchart. So like you are writing the software, okay, the type of flowchart. Now this flowchart here basically, okay, contains, okay, 3 elements. Okay, 3 elements. First element here is your state box. So you will see a state box something like this. Okay, a square, rectangular. Okay, rectangular box here. You have an entry path, one exit path, and these are state box here inside. Okay, you might have something, may or may not. That's why it's optional. But here, okay, we will write to you here, no, in the binary. Okay, what does it represent? So this is the state code. Okay, represent something like these nodes in the state diagram. Whereby in this diagram, let's say for example, I start off with 0, 0, 0. Then you're going to find that this part here is a 0, 0. And of course, okay, here got 1 go out, and maybe, okay, a 1 that come in. So this is exactly the same step. Your state box, same as these nodes in the state diagrams. Okay, from this state box here, their output, okay, their outputs here. may, okay, go into a so-called decision box. So in this decision box here, we are going to decide whether result coming out is a true or false, or represent in binary as true is a 1 or is a 0. So if it's a true or 1 here, then you follow this path. Okay, false, you follow another different path. So you are going to find that your decision box in a diamond shape here, they have 1 and 3 path, okay, and 2, okay, exit path as in this case. Okay, so this exit path here may go into another state box. All right, so it may go to another state box, or it can go to another, okay, this decision box, or even, okay, go to a conditional box. Okay, their output maybe go into the conditional box. All right, so may go this one, or this one. So what is a conditional box? So in the conditional box here, you may find that, okay, inside here, I will tell you the output. Okay, conditional output. And these are conditional box, okay, usually used in the milli model. Do you still remember the milli and more model? Milli model and the more model. Inside the more model, inside this our state diagram, let's say, okay, you are going to find that, I have a 0 over here. So this 0 is the output. This is the state. Whereas in the more model, I am going to put it this way, okay? If input is a 0, I output you a 0. So this is the milli. This is the more model. All right. And over here, I tell you here, this is the state 0, 0. All right. So milli model will be of this form. More model will be in this form. So if you see, okay, that you have the conditional box here, so you are going to know that, okay, I am trying to represent it as in this form. Okay. So the input to this so-called conditional box here come from the output of a decision box. Okay, come from here. So they decided, okay, that this is something correct already. Okay, they go into this path. This one, they go to a different path, because all the conditional box here having 2 exit path. So 1, for example, 1 come to here, 0, you go to another, no, maybe a state box. All right, so ASM easy, only 3 components. First component, state, okay, state box, okay, which you see like a rectangular. Second component you see is a decision. So they are making decision, checking, for example, what is the conditions of the input. So it is given as a diamond. All right. Third decision box here is a conditional. Third box here, third elements here is a conditional. Okay, box which is given like this is an ellipse like that. Okay, this is a 1. Alright. Okay, only 3 types of these elements here. Okay. Now here they tell you here, every state in the ASM chart here is associated with ASM block, which may contain one, okay, which may contain the other 2 basic ASM element. All right. The ASM block illustrates here has 1 input path and 3 exit path, which will link to another state box, which in these terms here, okay, we will call this one, this whole thing here as a ASM block. Now, ASM block here can be very easy. Let's say I have only 1 state. Okay, let's take it as example. Enter start. State box here, I label this one here as 0, 0, for example. Clock comes, I go to another state, let's say another 0, 1. Okay, so if this is the case here, your ASM block contains only this one. All right. But in some cases, okay, from this ASM, this state box here, which we label as 0, 0 now, you find that, okay, it may go through a decision checking of X. Is my x equals to a 1? Yes. Then I go and check my y. Is my y equals to a 1? Yes. Then I give you an output. Okay, Z. Then go out. Okay, this go out here will be going to, for example, another state box. Okay, now, so from this state box, okay, 0, 0, let's say now go to 0, 1, go to this 1, 1, go to this 1, 0. So the timing or the contents, okay, of these whole things here, we are going to call it as ASM block. So it's going from one state to another state, can be as easy as a single state box or containing the other two, okay, basic element. The other two are, so the other two here can be more than, okay, one element being, okay, checked here as well, especially, okay, your decision box. So this whole thing here will happen something like in your one clubhouse. Okay, they call it as ASM block. Right, looking at these three elements here now, okay, we look at very simple example. So this is similar, okay, to our state diagrams here, okay, like a counter. Okay, I am going to label this one here in terms of labeling. I take it as S0, but in binary, it is assigned as 0, 0, 0. So your state assignment here is S0, you assign it to 0, 0, 0. Okay, and your list output here actually is this one. All right. Or if you want to have different output, you can put it inside. But in this case here, okay, your output here, these are my outputs, 0, 0, 0. Then S1. All right, clock power comes. I'm going to move from S0 to S1. S1, I assign it as 0, 0, 1. So keep on moving. Another clock pulse. I go to S2, okay, with the output of or the state of 0, 1, 0, and they continue. Okay, a very simple, okay, ASM chart. Okay, this ASM chart here, we call it ASM chart here. Okay, ASM chart here. Okay, used to replace your state diagrams. So in this case here, there's no external input or no external decisions that I need to make. I just follow the clock and I am going to repeat the process or rotate the process here. All right. So let's say make it slightly more complex. Now we add in this a condition, okay, or a control here. Now this G here will decide, should I, okay, continue with the next count, or should I, okay, repeat, okay, or go back to the initial starting count. Let's take for example here. Now I have a S0 first state 0, 0. Now in this case here, G means it's the G is always there, but G in this case here can be a 0 or a 1. So G is a don't care terms. G can be a 0 or 1. So no need to check the G. With the clock power comes, I go to the next state S1. Subsequently, same thing. I no need to check the G because G is a don't care. All right, so I better put this one to indicate this is a don't care term. It can be 0 or 1. Then you find that, okay, S2, okay, is the next, okay, state that system is going to come in. Okay, then once you reach the S2, check the G. Okay, what is the conditions of my G? If my G is a 1, I continue, okay, move on to state S3. If G is a 0, okay, so I move back to the initial starting state. So G in this case here, okay, control. Whether I should count from 0, 0, okay, 3 states, 0, 0, 0, 1, 1, 0, or going to count 4 states up to my 1, 1 here. Okay, this is my 1, 0. This is a 0, 1. So G will control, okay, whether my this scale of counting here is 3 or 4. So another very simple, okay, ASM charts, you add in this. Okay, if this style of chart here, I want to draw in the Kano map. Okay, sorry, in the state diagrams, I can draw it as in this case. Okay, this is the S0. Okay, let's finish this one first. So I got the S2, I got a S3. All right, so no problems, all will come to here. Then now this part here, G, okay, is a 0. Sorry, if G is a 0, I go back. Okay, this one here, when G is a 1, I proceed with S3, then only go back. Okay, so this one here, okay, there's no output. So what you can put is this is don't care, don't care, don't care. Or if you want to make it complete, also can, okay, 0 or 1. Okay, both 0 or 1. Okay, they all go. All right, so from these state diagrams here, we convert them into something like a flow chart. And we call this one here our ASM chart. All right, okay, slightly more complex. So let's see the whole picture. Now, my state diagram, S0, start, initial state. Clock power comes, I come in. And now I'm going to check the condition as my X here. If my X here is 0, I am going to stay. So this is the same as saying that now I have a S0. When my X is a 0, I stay. Okay, I stay. When my X is a 1, okay, I am going to go to state called S1. Okay, this one. Okay, then at the S1, I check X again. Okay, if my X is a 1, I am going to this way. Means I stay. Okay, X is a 1, I stay. When X is a 0, I move on to my state called S2. Okay, S2. And I'm going to check my X condition. Wow, the state box are missing. Then for us to learn only. So in this case here, I put a 0 here, I put a 1 here. So if this is the case, you find that, okay, when X is a 0, I am going to go back. Okay, I am going to go back. So I go back to S1 where my X is a 0. All right. What happens when my X is equals to a 1? I also go back, but now I go back to S1. Okay, this one here, go back to X1. Okay, X1. And I am going to output you a 1. Okay, in this case here is the Z. Okay, so X is the input, Z is the output. Now, in the state diagrams here, we have every one of them, okay, containing the input and output. So if you want to make it complete, you find that, okay, you add in this one. So at this case here, there's no output or output is a 0. Okay, this is a 0. I go back. All right, so this is the 1. So in this case here, you find that there's one additional because, okay, because you have 3 states here, you know lah, your these flip-flops 3 states here, I need 2 flip-flops already. So that is to say that, okay, this flip-flop here may generate an additional state for you, which we are going to label it as S3. You can say as unused, okay, don't care. All right. Or you can say that, okay, the moment if, okay, my system start from this state S3 or in binary as 1, 0, then when come to next clock pulse, please go back to S0. Okay, join the S0. So in this case here, my X is a don't care. I never check my X conditions. Okay, here I don't want to put X because confusing, right? So I put a dash here to indicate, okay, you no need to bother about the X condition. The moment clock comes, okay, next state, okay, you join this the normal state that which they are supposed to go through this path. All right. So this flow chart here or ASM chart here, okay, is similar to this flow of state diagrams. So I hope you all can relate these two. All right. Okay. So in this parts here, you find that, okay, I'm actually checking, okay, the sequence, the 101 sequence. Okay, let's check and see. So move on, move on, move on. Output you a 1. Okay, this way, this way, this way. So because you have a 1, 0, 1. After this one, if you got another 0, 1, their output, okay, you get a 1 here, you get another 1 here for the case of your output. Because overlapping of 1, 1. That's why, okay, they go to state as 1, okay, when the last 1 here comes in. Okay, because of this overlapping, they accept it as, okay, they are going to output you another 1. All right, rather than every time go back to the initial state, okay, that makes the design here very slow. Okay, so this ASM block here is a 101 sequence detector. Convert in the state diagram, it looks something like this. Okay, now this ASM chart is not just draw flow charts only. We need to make use of this ASM chart here, and we need to implement them in the hardware. So how we are going to convert this ASM chart here into hardware? So we will look at this example. So I want to design this one. So instead of, okay, start from a state diagram, we start from ASM chart. Okay. This is a state, I label it as B. Okay. Starting the time, I need to tell that, oh, I'm at this state, so it's the starting state, so Z1. My Z1 here will only check whether I'm at these states or not. And I'm going to use 2 flip-flop, one label B, the other one label A for this design. All right, clock comes with no conditions. I'm going to move on from state 00 to state 01. All right, so before clock comes, I need to sort of, okay, check, okay, what is my D conditions, 1 or 0. If it's 1, okay, my next state will be S, or label as 1, 1 in binary. Else, okay, they go to R, label as 1, 0. Then they go back. Okay, for the case of 1, 1, they move on to check another D input, whether is it a 0 or 1. If D is a 1, yeah, they say that, oh, successfully detect something. Okay, my Z2 will show you a 1. So this part here, Z2 comma out, indicate to you that Z2 output you a 1. All right, then they are going to repeat the process. And based on these diagrams here, okay, we are going to produce our state table. Now, this part here is similar to our state diagrams. Now, in our sequential design, after the state diagram, the next step that we are going to do will be the state table, right? So similarly, this part also same thing. I am going to get my state table out from here. So in my state table here, of course, okay, I need to prepare my present state, next states, and so on. So you start off with this one, your present state. Okay, since they label BA for me, I follow BA. All right. Then over here, you'll find that, okay, I need to know what is the input condition for me to go. So the way of these state diagrams here, just a little bit of modifications only, okay? So this is my state conditions. My input conditions. Then subsequently, okay, with this input condition, where am I going to go for the next state? Okay, so we do this one first. So starting 0, 0, that is my present state. And these are present states here tells me that I got an output, my output Z. So add additional column. And you know that you have two output, Z1, Z2. So we prepare the two output together. All right. So this is Z1 here, only checking the state. So the moment I saw this present state here is 0, 0, my Z1 will be a 1. This one don't leave it blank, it is a 0. Okay, so this one relate to the present state. And with this one here, no conditions, no condition. Either I put a dash, okay, or I put a don't care. All right, either a dash or don't care. You are going to find that they are going to go to the next state, 0, 1, which we are going to call it as a plus or and your B plus. All right, and next, after one clock pulse, this next state will become the present state. Then now I need to check the decondition. So Sukahati, okay, whether you want to check the 1 first or the 0 first. All right. So in this case here, if I go for 0, then you find that this part here we will write as, because D is a 0, we write as D bar. Okay. For D bar, they are going to go to the next state of 1, 0. So in this case here, what is the output that you're going to see? Both are 0. So still present state of 0, 1. If D is a 1, D is a 1, I'm going to go to 1, 1. Okay, come up to here, and you are going to find that my output still 0. So you find that, okay, for the present state now, okay, sometimes we need to check more than one thing. Okay, proceed. Okay, 1, 0. Let's say I follow the 1, 0 here. Then you're going to find that I need to go back to the next state of 0, 0. So under this condition, my output is still 0, 0. Okay, any condition that you need to check for any of the input variable here? None. Okay, no conditions. Okay, so if you are following this path here, then this is the 1, 1 now. 1, 1, I need to check the D, which is a 0. Okay, D is a 0. The next state they are going to go is a 0, 0. What is their output? Also 0, 0. If D is a 1, okay, they also go back to 0, 0. But your Z2, okay, Z2 will be a 1 here. That complete this state table. Okay. Now, once we got this ready, okay, of course, the next steps here, we need to decide what type of flip-flop are we going to use for this implementation. Let's say, okay, we use D flip-flop. Okay, use D flip-flop. Then you are going to find that, okay, using D flip-flop is the easiest one. So with this, okay, you'll find that, okay, I can, I can, okay, prepare, okay, an additional, okay, columns. So this additional columns here is saying the next states, okay, or the input to the flip-flops. What is this? Okay, after this, okay, if we decide that, okay, we want to use a D flip-flop for the implementation, then you are going to find that, okay, I add in extra columns here, input to my D flip-flops. And as you know that, okay, these are input to the D flip-flop, okay, is depending on what is the Q plus that you need. Q plus in this case here will be exactly the same as your D input. So this is my Q plus. Okay, this is my Q plus. So my input, okay, to this D flip-flop here, I made a mistake, should be BA. okay, BA. Okay, so input to this D flip-flop here will be your DB, B first, then only your DA. And you find that this part here is exactly the same. Basically, because this one, this is Q plus, this is your Q plus. Okay, so now this one here you are doing for your D. So you are going to find that Q plus same as your D. So you know that your Q plus going to go to 0, 1. Okay, D input follow 0, 1. Subsequently follow. Basically, I'm trying to tell you here, just copy. But for some of the students, okay, they already know it. So if you have done it, okay, you know that actually this one here, if you skip also, no problems. This will be your D input, exactly the same as your D inputs here. Okay, now based on this table that I already generated here, we wanted to find what is the input, expressions to my D flip-flop. Example here, DB. So I can actually get the DB, directly from here. Then you find out, this DB, DB, exactly the same here, is given as this one. This is a B, this is A, so it's a B bar A with the conditions of the D bar. Then another one. So basically, I'm looking at the one here. For this a simple design, I look at the one here. Okay, so this is one of the condition. Another condition to give you a one here is with B bar A D. Of course, if you see this, you know that you can simplify them to the B bar A. That is the input to the DB. Next, continue with the input to the DA. This one, this one. So this is a B bar, A bar, or with B bar, A, D bar A, D. Okay, of course, if you want to simplify this, no problem. Take out the common B bar. This is A bar plus AD. Still remember these expressions? This expression here is exactly the same as the D. All right, so I simplified this part to become my A bar plus D. So this is my DB, DA. Of course, Z1 also, single one. So this is the B bar, A bar. And my Z2 will be given as this one with B bar, A, D. Okay, so this is the very simple design. I didn't use Kano map because here, containing only two single one. Okay, and of course, we also can make use of a Kano map to do the checking. Okay, confirm that my this part or this solution that I simplified is the correct one. So how to make use of a Kano map in this case here? So similarly, you find that because my present state contain BA and I have only single input that is the D. All right. So I am going to prepare Kano map just for the DB and DA, because the Z here contain only a single one. There's no difference, whether I prepare Kano map or I don't prepare the Kano map. So if this is the case here, you'll find that, you are going to put BA. BA, All right. So this will be my D, My D got 0, 1. This is 0, 1 here. So this is 0, 0, 1, 1, 0. Okay, first one, how to fill up my Kano map here. BA, when they are at 0, no need to check the conditions of the D. I am going to tell you here, my next state is 0, 1. 0, 1. So, of course, first, when D is a 0, you are going to go to 0, 1. D is a 0, you go to the 0, 1. When D is a 1, you also go to 0, 1. This part, I repeat. This one here, D can be a 0 or 1. D can be a 0 or 1. So when D is a 0, I fill up 0, 1. Okay, 0, 1. When D is a 1, I also fill up 0, 1. Okay, so done for the first one. Second one, for the case of 0, 1 in the case for the BA condition, 0, 1. Now I check D is a 0. D is a 0. I go to 1, 0. So I go to 1, 0. When D is a 1, I go to 1, 1. Okay? 1, 0. This is the 1, 0. Okay? No condition. You go to 0, 0. Okay? Whether D is a 0 or D is a 1, both you go to 0, 0. Lastly, 1, 1. Okay? 1, 1. When D is a 0, 0, I go to D is a 0, I go to 0, 0. D is a 1, also I go to 0, 0. But they output you, okay? Different conditions of the output lah. All right. So with this, okay, we double check, okay, whether the simplifications is it correct by doing looping. So our looping here, this is the one here and here. And you'll find that, okay, this part here is the dB that I'm talking about. This is the dA. Okay, B bar A. B bar A. All right, B bar A. This one here, first is B bar, A bar, plus, okay, this is the B bar D. So confirm this result here with what we obtained just now. So B bar, A bar, B bar D, and DB is the B bar A. So of course, for simple one, okay, we go through Boolean algebra, no problems, okay, we can get what we want. But for more complex one, okay, Kano map is still the first choice. All right, we try to look then and we simplify them via this Kano map. Okay, so once we got this equation, of course, okay, next steps here is draw out the circuit. Okay, draw out the circuit. Implement the circuit, okay, like what we have done earlier. Okay, so this is using D flip-flops. Answer is here. Need one? Okay, next we proceed. If now I tell you here, I want to implement this design here using JK. Then how am I going to do it? Of course, okay, if you are using JK, the application table of JK should come up. Okay, always write at the side there for you to refer. Okay, so we have our Q and our Q plus. We check our JK. Please remember this one for those, okay, haven't remember this. Okay, so my J is 0, K can be 0 or 1, so don't care. J must be 1, K can be 0 or 1. So this one, reset, okay? Reset conditions. So K must be 1. Okay? If it's 0, 1, reset. If it's 1, 1, toggle. Therefore, this is a don't care. Next. When this is 1, I must make sure that my K is a 0. If it's 1, 0, okay, set. 0, 0, follow. So don't care 0. So memorize, okay, this application table in this way. So after this, okay, we prepare this state table. Similar, you have present state, you have input condition, you have your next state. All right, you can write it as B plus, A plus. Then later on, okay, you have trying to find the input to your JK flip-flop. So whether you put which one first are not important, as long as you have all the columns. Okay, that's one I just modified. So you find that now I need to find the input to the JK flip-flop. So what I did here is, this is the one that I want. So yellow, wait, cannot do this way. Okay, I go for yellow. Okay, yellow, 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 yellow. I check yellow with yellow, and all right, then next, let's say use green. Okay, green with green. So this is again, okay, this is my Q. This one here forms my Q plus. All right, so I compare. For the case of B, okay, so fill in the JB, so 0, 0. 0, don't care. So you put in 0, don't care. So 0, 1, set. So it's 1, don't care. Okay, 0, 1, 1, don't care. 1, 0 is a reset. Okay, don't care, 0. 1, 0, same. All right, so if you see same, you fill up. So here, do the same thing, compare the green with the green. All right, so you get all this. And this X is actually the don't care. All right, so I don't want to repeat this part already. I think you all should know by now. All right, so with this one here, now I prepare my Kano map. So since I'm using JK, you know that, okay, JK, each JK having 2 input. So I have my JB, KB, and the JA, KA input. So I filled up, okay, location like what I have just now. 0, don't care. First one, 0, 0, don't care. 0, don't care. For this 0, don't care. All right, 0, don't care, 0, don't care. Next, okay, I fill in, okay, 0, 1. D is a 0, 1, don't care. Another 1, don't care. This 1, 0, you're going to find that is a don't care 1. So I fill in don't care 1, another don't care 1, because D can be 0 or 1. And lastly, okay, same thing here, 0, 1, okay, for here, and 0, 1 for the last combinations here. So same positions I filled up for my JA and KA. And this part here, you're going to find that, okay, result that you're going to obtain is more simple because of the don't care here. So this one is only A. This one, you look all of them, you get your 1. All right, this one, B bar. All right, this one, try to look as big as possible. All right, so this is the one that I am going to have. And my output here, I repeat, there's no change. Regardless what type of flip-flop that you're using, my output remain unchanged. So you can build up your circuit, okay, based on all these equations here. Okay, so this is the way that we design this. And now another design method here. Now I'm going to use a multiplexer, a D flip-flop, okay, for one state. If 2 states, use 2D flip-flop and decoders for the design. So how am I going to do this design here? Basically, I just modified the table a little bit. So same circuit that we are talking about. We have this present state, our input condition, our next state here, the B plus, the A plus. Then now, because I'm doing multiplexer, my multiplexer here will depend on the state that I'm having. Okay, here got 4 states. So this multiplexer that I'm going to use will be 4 to 1. Okay, 4 to 1 because here got 4 states. So 4 to 1 means that they are going to have 4 inputs. And which one actually control their inputs here actually is the state. The selector is the state. So these 4 input here, what is their condition that you are going to put in here. Okay, this multiplexer, I repeat here. So the selector here, the S1, S0 here will come from your state. So since my MSB is B, so the B will be connected to S1. A will be connected to S2. But this is 0, 0. Okay, 0, 0. So they choose this as 0 as the output. What should I put, okay, to these zeros inputs here? So it depending on, for the case of D flip-flop, because the next state exactly the same as the D. So you find that I basically take this one, put this one here. And this one I put here. Whereas when this is a 0, 1 the time, okay, I need to check these conditions. So for the case of B, you find that you don't need to care. All right, don't need to care. Okay, both will be giving you the 1. So this this is for the B. For the B, I do the first one for the B. So for this case here, you find that, okay, both are giving me 1. For the case of A here, you find that, okay, my this one here depends on D. So D will be the 1. Okay, this one here depends on D. If D is a 1, yeah, they are going to give you a 1. If D is a 0, they are going to give you a 0. So for the second input here, I connect it to D. All right, first one, this is a 1. Then what about the third input? Okay, third input to this multiplexer here. To select the third input here, of course, your BA condition now must be 1, 0. So you put here 1, 0, here also 1, 0. So with this condition of 1, 0 here, you find that don't care what is the input coming in, both, okay, output should give you 0, 0. So I want my output to be 0, 0. So of course here I input 0 to it. Okay, and last one, 1, 1 also. No need to care what is the conditions that I'm having here. Both are 0. Okay, both are 0. So I got a 0 inputs here, another 0 inputs here. So this is my multiplexer. Okay, for the B, this multiplexer here for the A. This B multiplexer here is actually replacing this type of combinations. Okay, so instead of, okay, go and work out, okay, from Kano map, what is the expressions for the input to the DA or DB here, I make use of multiplexer to generate the combinational expressions, which is here. Okay, and combination expressions for this one. We can double check. Okay, for this case here, first one here, let me just confirm, this is a 0. So what is the expression for this B here? Okay, this B here or QB here. You find that, okay, QB. Okay, this QB, remember how to get the expressions or not? Okay, first B bar, A bar, let me write here. Okay, how to get this QB here? You find that, okay, when we want to find the expressions here, what we are doing here is we generate all the possible combinations of my selector input. Okay, 0, 0, 0, 1, 1, 0, 1, 1. And if I fill in 0, 1, 0, 0 over here, then you find that, of course, these are all 0. What is the result that you obtain? B bar A. So same as what I'm having just now. Okay, then what about the QA outputs? Okay, you find that, okay, I do the same thing. Now I'm going to be lazy a little bit, skip these two. So I have a B bar, A bar. This is a 1. Okay, filling a 1, no need to write. And next, okay, I have a B bar, A, D. All right. So for using multiplexer, you find that we normally don't simplify them. Okay. We just leave the answer as in this form. Of course, okay, if you say you use a logic gate to do the design, then I am going to replace this one here with this one. If multiplexer, no need. You just leave your answer as in this form. All right. So here I'm trying to tell you multiplexers here has been used to replace those logic gate for this method of design. Right? So I managed to find my this input to multiplexer B and A already. Okay, then I start to draw out. And you're going to find that this design here very systematic. Okay, so this one here, like what I mentioned just now, I connected to B because B is the one more significant. Okay, the S0 I connect to A. So to make the design here neat, I have both, okay, label it as in this form. Okay, the S1 and the S2, instead of putting it at the bottom, I move it to the top. Plot diagram, you can do so. So both of this one here, okay, being connected, okay, to my state. And this is the input that I put in just now. Okay, their output go to the D because what I'm generating here, Q same as the D ma. Okay, so their output, okay, we connect it to the D input. Okay, and this one will be output here, come back to this. And decoder in this case here is a 2 to 4 decoder. When your QB and QA both are at 0, 0 that time. Here will tell me that, okay, this part, I'm at the state P. Okay, if this one turn on, I'm at state P. My output, okay, Z1 is a 1. Okay, Z1 is the same as B, A, then your, okay, B bar, A bar. What is B bar, A bar? B bar, A bar also same as your P. Look at the earlier parts here. B bar, A bar also same as my P. Okay, followed by Q, then R, S. All right. So my output here turn on, indicating that I am now at the P state or the B bar, A bar, the 0, 0 state. Okay. If this one now here change to 0, 1. Okay. This is more significant. So 1, 0. Okay. More significant. Then you find that, okay, I will be, okay, showing you the Q state, 0, 1. Then followed by 1, 0, show you the R state, show you the S state. And your Z2 is given by this expression BAD. BA in this case here is equivalent to the S state. So same as your S and with your D input. Okay, so I got my output from here. So this design here make it, okay, the whole thing here very simple and very systematic. I can see my state from here. If I want to see the binary one, I see from here. All right. So only thing you need to remember is your multiplexer, the state selector here. The selector here is connected to the state output, your Q output. All right, such that I can generate, okay, the output here that containing the state, because this one here forms the selector. And this part here, to make it complete, okay, I just write down the expression for this one. This is the same as your B bar A, B bar A. So 0, 1, 2, 3. This is B bar A. 0, 1, 2, 3. And this outputs here is taken as this one. is the B bar, A bar, or repeat. This one is a B bar, A, D. All right, B bar, A, D. Then the rest are the same already. Okay, next, proceed. Another example. So in this example here, based on this ASM chart here, I am going to design using discrete logic gates. That means that I need to work out what is the input to the D flip-flop instead of using multiplexer. Then later on, okay, I'm going to design using discrete logic gate, but now it's a one flip-flop for one state. If here got two states, okay, here you say it's two state, you say 2D flip-flop for the first case. But this is one state of 0, 0, second state, third state, and your fourth state. So all in here, one D flip-flop or one state means that I am going to use 4D flip-flop. Because one output, okay, the flip-flop output turn on, means that, oh, I'm at the state 0, 0. Second flip-flop turn on, for example, I'm at the state of 0, 1. Then followed by, I'm at the state of 1, 0. So instead of looking at the two output, okay, from the flip-flop, I look at individual output, then I can tell you exactly, okay, which state am I in now. So we look at, okay, first one first. First one here is more traditional. Okay, we are going to design using discrete logic gates with one flip-flop for one state. One flip-flop, okay, representing, okay, these are A, another one representing the B. Okay, so as usual here, I will start to prepare the state table. Okay, I'll prepare the state table. So we prepare it as, okay, follow this, B, A, B. So now present state. I have A, B. Okay, some students, okay, they want to write the next state over here. Like I say, okay, no problems, as long as you have all the columns. But I would prefer to put the input condition. Okay, my input conditions here now in this case here got X lah, got Z lah, some more got XY lah, XZ lah. Okay, so you may have quite a lot. Okay, then now only my next state. My next state here, because this is A and B, and I know that if I'm using D flip-flop, my next state will be exactly the same as the D input. So I can write it as a DA, DB, or I can write it as a QA, A plus, B plus. So suka hati, all right, because it's a D flip-flop. Then over here, I have output. Is there any output? Yeah, P, okay, output. P here, okay, output P, Okay, we start off with the present state, okay, 0, 0. Now this 0, 0 is being represented as S0. So for us to know that this is the state assignment. Okay, what is the conditions, okay, for me to go to the next state? So we check here. Or here. So this is more straightforward. So I will go to the next state of 1, 1. With my X here is equals to a 1. So X is equals to a 1. So I write it as this case. X. What is my output? 0. So I already done this one. Okay, then now I go to, not finished yet because you have to follow this path also. This path also. So with this path here, you find that, okay, am I making a mistake? Yes, sorry, this is a 0, so x is a 0. Okay, next, when x is a 1, I go through this path. So once I go through this path already, okay, another decision I need to make for the case of my z, when my z is a 0. Next, okay, when my z is equals to a 1. So when it is 0, they go to 1, 0. And of course, output at this time here is 0. When they go through this path, okay, then they are going to go to this one here called as 0, 1. Still output me a 0. So this is a 0 first, because, okay, I must reach, okay, S2, then only output you a 1. Okay, so far I have finished, okay, checking all my present state of 0, 0. So we draw a line. Okay, I proceed with 0, 1, go in order. Then I need to check my xy. This is xy together. So xy. All right, xy. And I will need to go back to 0, 0. If this is a condition, this is the 0 output. If now the xy are 1, okay, and these two, you got a 1 here, then you find that you are going to go to the state 1, 0. And at this instance, your output is still 0. Okay, I finished checking my 0, 1. So proceed with, maybe we go for 1, 0 first. Okay, 1, 0. And if you are at 1, 0, okay, your P is a 1. Follow the present state. Okay, follow the present state. P is a 1. With no conditions. Okay, with no conditions, I will go back to 0, 0 state. Finish checking for the present state of 1, 0. Then I proceed with the present state of 1, 1. So I go down, I check if my x and with my z are 0, I will go to 1, 0. I output you a 1. I output you a 0. 1, 0, output you a 0. And if my x, z are 1, okay, when I end them together, then you are going to find that I will need to go back to 0, 0, and my output is a 0 in this case. So I finish, okay, transform these ASM charts here into the state table of this form. Of course, like I say, okay, you can do your DA from this table here, or you can have your Kano map. So let's say now, okay, I want to do it for my Kano map. Okay, for Kano map. So you are going to find that for this part here, if I want to do for Kano map, it will be quite difficult in the sense that now A and B, you have A and B. You also have X, Y, and Z. So this part here is 5 input variable. Present state or the state AB, 3 inputs, X, Y, Z. So we try both. So first one here, we just get, okay, the input from here. Okay, directly, okay, get our DA from here. So to get my DA here equals to a 1. So what is the conditions that I need to take note? So you find that this one, and this 4. There are 4 ones here. So first one, A bar, B bar, X. Okay, A bar, B bar, X bar. All it with this one, you get is again A bar, B bar, X, Z bar. Okay, done for this one. Next, proceed. I have this one here is A bar B, and this is XY. Last one is A bar B, and this is XZ. Okay, of course, these are XZ. Okay, you can apply De Morgan's theorem. All right, De Morgan's theorems. So here we simplify, okay, step by step. So from here you get is A bar, B bar, these two, so that you can see clearer. And this one here, nothing I can do. So it's A bar B X Y. This one here, I'm going to get is A bar. I apply De Morgan's theorem. I'm going to get X bar plus it with Z bar. All right. So here, simplified, giving you okay. This part here, nothing I can do already. Okay, and this part here is A B. Okay, so we leave it as in this form. Why I leave it in this form? Because these two are the same. Okay, so therefore I can now group these two together to form my A bar B bar plus AB. Okay, X plus Z plus the A bar B X Y. And if you remember, this is actually X naught terms. Okay, X naught terms. The X naught terms here tells you that it is like this. Okay, and X plus Z. Of course, if you don't see it, okay, you don't use X naught gate, you use AND gate and OR gates to form these expressions. And this is a result that I obtained, the most simplest one for the case of ZA. Right, it will be given by this form. And for the case of this DA here, DB here, it will be easier because we have less term. Okay, less term. First one is A bar, B bar, and my X bar. This one is A bar, sorry, A bar, B bar, X Z. And you find that you can simplify these two. All right. And this one here, you're going to have your A bar, X bar, X bar plus A bar, B bar. That. Yeah. So this is the expressions that you are going to have for the case of TB. Of course, PA is very easy. P is very easy. Okay. P is just the same as your A, B bar. That's it. Okay, so this one here, I'm using Boolean algebra to get it done. Okay, we say that we can actually implement this table here, okay, making use of Carnot map to get these expressions. Okay, let's try it. We want to do it in using the Carnot map. All right, so I have a Carnot map on top here. Now, based on this table, I'm going to fill up my Carnot maps here. Okay, so I'm going to use for DA, for DB. So this is for my DA. And suka hati, okay, actually suka hati saya lah. Okay, how am I going to label this part? But here now I'm going to follow this one here as AB. This one take XY. So this is the Z. Okay, Z Z bar Z. So same thing, Z bar Z. So this is XY, this is AB. So, and this is 0, 0. Okay. So my I am going to fill in 0 for DA under these conditions. Okay, under these conditions. So X is a 1. Where is X equals to a 1 here? Okay, Z also a 1. So it should be this parts here. So you are going to find out, okay, with this, okay, X is a 1, Z is a 1, Y in this case here is a don't care terms. Okay, Y is a don't care terms. So I am going to fill in A. This is A. Okay. Yeah. Okay, so this one I'm going to fill in here. X is a 1. Okay, X is a 1. Z also a 1. Okay, for the conditions of A, B are 0, 0. So you can do the same thing, okay, for the case of Z. These are dB, same location, you fill in the 1, 1 here of this. Okay, then we proceed. X, Z bar, which is this 2 now. I'm going to put in 1, 1. Okay, X, Z bar, I put in 0, 0. Next, this is a X bar. Okay, X bar. So what should I put here? Okay, what should I put here? Your Z not mentioned here, isn't it? That is to say that Z is a don't care terms. Okay, so 1, 2, 3, 4. Z can be 0, can be 1, but my X must be a 0. X must be a 0. Okay, so when my X is a 0, I'm going to fill in this one. This one. I fill in 1, 1. I also fill in 1, 1 here. Then next, okay, this one here, I fill in here 1, 1, here 1, 1. Same locations. So I finish, okay, checking this part. Okay, horizontal. Next, consider the 0, 1. Okay, 0, 1, which is the second row. All right. So for the case of second row here, this is both okay. X and bar here equals to these conditions. Now double check here. This is actually same as X bar and your Y bar, right? If I apply De Morgan's theorem. So either my X is a 0 or Y is a 0. Either one is a 0. So my X is a 0, okay? Or my Y is a 0. So whichever with a 0 lah. Then I'm going to fill it in with these conditions here. So do one by one. Okay, no problems. Do one by one. So first one we do is a 0, 1. X is a 0. When X is a 0, all right, X is a 0. This is a 1. Okay, there's no Z here. So these two that we are talking about, X is a 0. Then you are going to fill in here with these two. You fill it in with 0, 0. You fill it in with 0, 0. Same argument, I filled up for these two as well because of this 0 here. Next, we try to check y equals to a 0, which is here and here. We have done for this one. All right, so no need to worry about it. Then we just, fill up this. Here is a 0, 0. This one here also 0, 0. Okay, so only this condition, both x, y are 1. Okay, this one here is reserved for this. Then you find that I'm going to put in here 1, because z can be either 1. But for the case of this dB, it's still 0, 0. All right. Okay, let's go for 1, 0, which is easy. So you find that no conditions, everything I fill it in with 0. Happy only. No conditions, everything 0. So everything is don't care for the conditions. Did I fill in correctly, class? I say 1, 0, right? So be very careful. So this thing always happens. So I'm trying to fill in the 1, 0, not the 1, 1. So please fill in here. This is because no condition. The next state you want to go is 0, 0. Then this one here, first, I check x and z. Both are 1. So x and z both are 1. This is the locations. So I'm going to fill it in with 0, 0. This one, for the case of A, also 0, 0. Next, we go for this one. So these conditions here very similar to what we are doing just now. Is the x bar plus the z bar. And my y here now is a don't care terms. So you are going to find that, this parts here for the case of 1, 1. As long as my z bar, I got my z bar, I'm going to fill it in with all the 1. Okay. This one here, I need to look for is the x bar. Okay, x bar. So you fill in here with 1, 1. X bar. Okay, so same thing here, the z bar. Okay, z bar, all are 0. You fill in this, 0. And this part here, because it's a 0, so you find that you also fill it in with 0 for this case. So this is the table that I'm having, for the 5 variables here. And we try to do the looping now. So, and confirm that, the answer are the same. So this one here, macam suka hati lah. All right, this single one here, you can loop it this way, or this one here, you try to reduce, try to reduce the looping by, taking this one with this one, because this is a 5 variables. Okay. And next, this one here, maybe I should use a different color for this. I'm going to take this one here with this one. All right, then this one here with this one. Okay, so this is my DA. So we do the DB one also. DB, this 4. Of course, okay, this one with this one. Okay, DB is easier, do first. So these parts here give you the A bar, B bar. This one, A bar, B bar, Z. Okay, plus with this one, you'll find that it's the same as your A bar, B bar, your X bar. So double check this answer with the earlier one. Confirm it is correct. Okay, DA is the tougher one. So we go for this one. And this one. Okay, you find that this is the A bar, B bar, plus it with AB. Okay, these two are, then it's in the Z there, isn't it? So Z bar. Okay, it's in the Z, so it's the Z bar. Okay, next. Next, I try to do this one. Okay, sorry, this one. So you find that it's a A bar, B bar. Okay, this one here is the X bar. Because I want to group with this one, no. Okay, plus now this green color one also, this is the AB X bar. Yeah. Okay, so both side one I done except now this the two, okay, individual, these two. So this two here is giving me the A bar B XY. Okay, and check this one here. I can actually simplify them by grouping this one as well, which is the same as A bar, B bar plus AB. And this one, I group them together plus the A bar B XY. All right, this answer is exactly the same that if I use this method to do it. All right, but of course, okay, depends on which one you think is easier. For this case here, I would think this is easier than fill up this column map, because fill up the column map, okay, time consuming and cannot afford to make mistake. Okay. But anyway, here is trying to confirm, okay, to you that, okay, I can get the answer either using Boolean algebra or using column map. Both answers should be the same. Okay. And there's no need to do for the output because only a single one that I see. All right, so we just leave the output as in this case here, directly from the truth table or directly from this state table here. Okay, so after getting this, of course, okay, based on these expressions here, we go and design, we draw out. All right, this part here is our state output. So for us to know the states here, I must see both A and B at the same time. Because if I cover the B here, okay, I cover the B here, then I ask you, okay, what is the state now? You cannot answer because you only see a single A here. Okay, so you must see both, then only you can tell what state are we in now. All right, so this is design here. It's a very convention and a bit time. Sorry, this are cost saving also. Why? Because we use only 2D flip-flop, and we try to simplify these parts here. Okay, as simple as possible. Okay, as simple as possible. All right, so Then you see, okay, look at the questions here. They also ask you to design using discrete logic gates, but now it's one flip-flop representing one state. All in there, how many states there? Okay, 4 states. There are 4 states. So indicates to me that I need to use 4 flip-flops. Okay, but this design is very simple. So in my case here, I just basically look at the table and I can tell you these expressions already. Okay, so we refer to this table. Okay, now I am going to have 4 flip-flop. So these are 4 flip-flop here. They don't represent A, B anymore, but they represent S0, DSO, DS1, okay, DS2, DS3. That is to say that now, if I look at individuals output, I can tell you exactly, okay, are they in these states or not? You need to spend a little bit more money because you're using 4 flip-flops, and the equation here may be a little bit more complex. All right, so how to get the expressions for this DSO here? So we check from this table. Yeah. So no need to keep on fig here, fig there. So I check on this table here. So in this table, you find that, okay, this is S1, S1, 01 is S1. This one represent S2, 11 represent S3. This is S0 again. This is S2, S0 again, S0. This is 10 means it's S2. Because now no more A or B, so it's represented, the state is represented by this S over here. So for my DSO to be available, so I go and check here. This is okay. Where else do I get DSO? Which is here. Any more? Yeah. Here. 1, 2, 3. Okay, for the case of DSO. So how to write here? Now to get this output here to be DSO here, this SO, I take S1, okay, with the conditions of this. All of it, second condition, S2 only. Third condition, S3 with XZ. X3 with XZ. Of course, okay, if you want to simplify, go ahead. If not, just leave it as in this form. So my this part here is try to teach you how to, okay, see these conditions. All right. And for the case of DS1 here, I will look at, okay, maybe DS1, I will look at this S1. Where is the S1? No more. Okay, no more. So therefore, over here, I will write SO with, okay, SO with, all right. Next, I will try to look for DS2. S2, S2, now with this S2 here, I start off with, okay, I must be currently at S0 if the input coming in is XZ bar, or I'm currently at S1, input coming in is XY, or if I'm currently at S3, input comes in is the XZ, okay, both bar together. So this is my DS2, input to my DS2. Lastly, okay, DS3, the one that I never highlight, this is the only one, okay, with the conditions of S0, X bar. And of course, now, okay, there's no more A, B, and C. All these are A, B. So therefore, my P cannot be in this forms here. My list of forms here actually is the same as S2. Okay, so P will be S2. Okay, so design here more costly but easy. So you find that, okay, for this part here, I can, okay, use 4 map. For these D flip-flops. Okay, maybe I arrange it in this form. So my clock now, I put it here. Okay, this is my clock. And the output. Okay, I assign accordingly. This is the S0. No more A, B, and C, A, B, So S1, okay, S2, S3. And this S2 is also your P. When this one turn on means that, oh, my output is 1, okay, for the case of P, okay. So this is the D input, okay. So since this is labeled as SO, later on, okay, I put inside a big SO inside. This is S0, S1, S2, S3 flip-flops. Then now what you need to do is, of course, okay, over here, you can have your so your S0, S1, S2 all come from here. Then later on, okay, you have your X, Y, X. You may need to have a bar. Yep, I have a bar. So you draw accordingly. Then you have your Y here. Do I need to have a bar for the case of Y? Let's double check. No need. So don't put because it's very, very complex. Then what about the Z? Z also no need. But maybe it's good, okay, to put also because I applied the Morgan's theorems. Okay, just put it. Okay, for the case of a Z, you put it. Okay, so you draw accordingly, okay, for this design here by tapping, okay, those are output from this circuit here. So you find out, okay, design here, oh, very fast, I can get the circuit, but of course I spend more money on this. This part here more complex compared to the earlier one, which is this one that I show you. Okay, that ends this lectures here. So this part I leave it for you all to draw on your own because if I draw it will be very messy. We can try that on the tutorial. Okay, is there any question related? Renjian so fast respond. Bubble means output is 1. Where got bubble? I think where got bubble? Which bubble are you talking about? Conditional box, conditional box. Inside the conditional box, no bubble also. Any idea which page? I still cannot understand your question. Z out means Z equals to 1, yes. Correct? Because normally we say no output means that it is 0, okay? When we got output, okay, then we put it as 1. Is this the questions that you refer it as a bubble? Wait, if Z only still 1, if Z only still 1, if Z only still 1, so you mean that, let's say for example, okay, this part here, I put as let's say I tell you Z, then yes. Okay, and sometimes, okay, it's written as like that. Okay, tell you that Z is a 1. Because if it's not being activated, it is going to remain as 0. Once it is activated, it will be a 1. I think clear. What about the rest? What's the difference with square box? Square box, this one. Rectangular box. This one here, state. Okay, this one here for output. Conditional box, indicating your output. In the Mealy, okay, Mealy model, okay, output is written inside the conditional box. In the Moore model, output straight away is inside the state box. Wait, if square, in that state only output equals to 1. In that state, yeah. The moment I see the state, no conditions, the output is a 1 already. Like in this case here, no condition. If I'm at the state of P, P, I call it P here, my Z1 will be a 1. No conditions. But in order for my Z2 here to become a 1, I must make sure that, okay, it comes from state 1, 1, then with the D equals to 1. Then I need, after this one here is being fulfilled, then Z only will become a 1 in this case. So this is mainly for Mealy model. This is mainly for Moore model. Any other condition? Any other questions related? There are a lot of exercises or the tutorial questions, okay, at the back, at the one link there lah, and can go and look for some past year paper, right, for these parts here, and give you one tips, this part here always come out, not a full question but half questions. Usually D lah. Usually it's D, okay, but this one here, if you are naughty, okay, I can change it to become JK, okay. Like macam ini. I don't want to actually see anybody fail, but if you really cannot make it, no choice, have to fail you. All right, education is not meant to fail you, it's to pass you, but you have to put in some effort to pass. Okay, if there's no question, we take a break, then we come back, okay, for tutorial, continue from last week. Okay, so take a 10 minutes break, okay, go and stretch a little bit. So 12, 5:05.